Okay. So in properties of fluids, there are many properties of fluids which we will be discussing. First is surface tension, the second one is viscosity, and the third one is flow of fluids. Okay. So today we will be discussing about surface tension of fluids. Now, from NEET perspective or from JEE perspective or from only from these two perspectives, it's a very important subtopic because you will see at least one question from properties of fluids frequently occurring in these chapters, in these tests, right? Exams. So if this is, first of all, let's define what is a surface. Okay. So if this is a fluid and the topmost layer of the fluid, this is the topmost layer of the fluid. Okay. Now, this surface is surface till what thickness? I repeat, surface is surface till what thickness? So this is the thickness of the surface. If I say this thickness is approximated to 10 to 15 molecular diameters. So molecular diameter is of the order of 10 to the power minus 10 to 10 to the power minus 12. Okay. So 10 to 15 molecular diameter is the thickness of it. Now, let's see what happens to the molecules of the fluid which are inside the or which are below the surface of the fluid. Now, what will happen here is this molecule will be attracted by all the molecules inside the surface, right? Neighboring molecules are attracting this molecules, right? They are exerting force on it. So net force acting on this molecule is zero. I hope all of you understood it. Yes or no? This molecule is attracted by all the molecules, all the surrounding molecules. Bhavani, understood or not? And that is why the force acting on this molecule is zero. Okay. Now, what happens is, if we take a molecule on the surface of the fluid, now what will happen to this molecule? See, its own molecules, its neighboring molecules in the liquid will be attracting it, right? But the molecules of air will also try to pull it towards them. Okay. So this molecule will try to break off with the molecules of the other molecules of the liquid. Got it? Yes or no?
Yes, sir.
Yes.
So there is an unbalanced force. There is an unbalanced force on the surface of the layer, right? And because of that, the topmost layer of the fluid seems to be stretched. And that is why the surface tension of the fluid comes in. श्लेषा समझ आया बेटा नहीं आया?
हाँ सर.
I'm explaining it to all of you, explaining it to you in Hindi also, ठीक है, and in English also, so that all of you should understand it. Because what happens is the surface is of 10 to 15 molecular diameter thickness, right? Any molecule, any liquid molecule on the surface is attracted by two types of forces. One is the molecular forces by its neighboring liquid molecules which are below it, and the molecular forces by the air molecules which are above it. And so there is an unbalanced force. Because of this unbalanced force, the membrane or the topmost layer of the fluid seems to be stretched. And that is where the surface tension comes in, right? Now, if I see the top view of this surface, this is how it looks like. And let's give a numerical expression, mathematical expression to this surface tension. So suppose this is a line of length L. Okay. And this is it. force F. Now surface tension S will be equal to force per unit length. This is the value of surface tension, right? This line is in equilibrium and it is pulled by both the sides, right? Because it's lying in the stress membrane. That's why the surface tension S is given as force per unit length. SI unit of surface tension is represented by S here, okay? SI unit is Newton per meter, okay? Now this is also given as change in surface energy per unit change in area. So what is this? This is change in surface energy. And what is this? This is change in area. So I'll explain it to you also. So here we have a U-shaped wire. Okay. And on this U-shaped wire, what we are doing is we are keeping a light, very light wire on it. The length of this wire is L. The length of this wire is L. Now what we are doing is, it's kept horizontally. We are dipping it in a soap solution and bringing it out. Okay, we are dipping it in soap solution. First of all, देखो सुनो मेरी बात. First of all, please understand it. I'll give you time to copy it, to write it down. Okay. So please, first of all, you understand it. Focus on the screen first, and then you write. Once you have understood, I'll give you some time to write it, copy it. Okay. सीखो पहले. So now what we are doing is we are just dipping it in the soap solution and bringing it out. So there is a soap film formed here. Okay. There is a soap film formed here. Now this soap film, see, all of you, you can see this book. This is the thickness of this wire. This is the thickness of this wire, right? Soap film is negligibly thick as compared to the thickness of the wire. So there are two layers of soap film. One is on the top side and one is on the bottom side. Two layers of soap films are formed, right? It will look like this. If I take the diameter of the wire as like this, okay, and this diameter, the black colored one, looks like this. So this is the top layer of the fluid and this is the bottom layer of the fluid. I hope all of you understood it. This is representing the blue wire, this wire, and this is representing the black wire, this wire. Okay, and this is their cross-sectional view. Understood or not? Bhavani, Janvi?
Yes, sir, can you please repeat this point? Length L and force F.
Which one? This one?
Yes.
See, surface tension is given as force per unit length, right? That's it.
Diagram, sir.
This diagram. This diagram. This diagram is the top view of this surface. Which surface? This surface. Top view. You know, you understand top view. If you see that surface from top, this surface seems to be like this. On that surface, we are drawing a line. That line is in equilibrium. It will be in equilibrium only when there are two forces acting in two different directions. Understood? Equal and opposite forces acting in two different directions. The expression for surface tension is given as F upon L. That's it. Okay?
Got it.
Now I was talking about this diagram. All of you understood this diagram? श्लेषा समझ आया बेटा आपको नहीं आया? इधर
Sir,
लक्ष्य
can you hear me?
Who?
I'm Jahnavi, sir.
हाँ जानवी, I can hear you. You haven't switched on your camera.
Yes, sir, I switched it on now.
तारिणी कृष्णा. शिव समझ आ रहा है बेटा नहीं आ रहा है?
Yes, sir. Sir, last class में cover हुआ था sir.
ये पढ़ाया था मैंने?
हाँ सर
Yes, sir.
प्रेशर इनसाइड द ड्रॉप भी
सर
हो गया
डिफरेंस
क्या?
तक किया था कवर।
देखो ये लक्षित तो पता ही नहीं है, क्लास में थे तुम, सो रहे थे लक्षित कुमार। चलो अब इसको कंप्लीट करने दो मुझे, देन वी विल स्विच टू सरफेस वो विस्कोसिटी, ठीक है।
यस।
तो बोलना था ना, इतनी देर से क्यों चुपचाप बैठे थे तुम लोग? Okay, these kids are saying they have already done it, so we'll complete the surface tension first and then we will move ahead, okay? So now what is happening here is, these are the two layers, right? Two layers of fluid. This is the upper layer, this is the lower layer, okay? Now what is happening here is, if you leave that thin wire frame, if you leave this wire here, what will happen is, this wire will be pulled backwards by this force because of surface tension, and the value of this force is SL because of the upper layer, and there will be another SL because of the lower layer. Understood? There are two forces because of surface tension. One is because of the upper layer and one is because of the lower layer. One is because of this layer, the other one is because of this layer. You can see here that this film will pull this rod towards this side, this film will pull this rod towards this side with a force of SL. I hope all of you understood it. And now the net force acting here is what? 2F, which is equal to 2SL. Okay. So now if you want to move this rod outside very slowly, right? Make an external force, apply an external force here, and this force should be equal to 2SL. Now what if this 2SL force, this external force will do? It will actually, if this external force pulls this wire by a small distance outside, okay, let's say this length is X. So we have work done by this external force is, it's a constant force. So work done by this external force is 2FLX. Force into displacement, right? Force is what? 2FL. Displacement is X. So this is whatever is the work done by external force, this is stored as change in potential energy, and this is equal to 2SLX. Okay. Now, what is change in area here? Change in area of this film is what? 2LX, right? LX on the top side and LX on the bottom side. And this is equal to S. And this is equal to delta U upon delta A. Right? So S is what? Change in internal energy upon change in surface energy upon change in area. I hope all of you got it. Yes or no?
Yes,
Shiv,
sir.
Pranav, Bhavani, bolo. Haan.
Yes, sir.
Sir, is the wire kept held free, or it is dipped in water?
It's held free, na. See, once it was dipped in soap solution and it was brought out.
Yes.
So there was a film on both the layers, both the surfaces, top
Once
surface and
again,
bottom
can you
surface. What?
once again, can you explain that?
What do you want me to explain?
That part, sir. That force external force.
See, SL force, you understood or not? 2SL force.
No, sir. I didn't.
See, because of surface tension, there will be some force acting on that length of the rod. Yes or no?
Yes. Yes,
And
sir.
that force is equal to what? S is equal to F by L, right?
Because of that soap film, right?
Yes. So F is what? SL. So the top layer of the film will apply a force SL on the opposite side, this side, left hand side. The blue arrows, right? The second film, the bottom film will also apply the same force SL. There are two films. One is at the bottom, one is at the top. So net force is equal to how much? 2SL.
Yes.
And that is equal to what? F external. We are applying an equal and opposite force just to keep this wire at its own point, at its original point. Okay. And that F external is now slightly increased so that the wire moves quasi-statically, very slowly outside. by a distance x without accelerating. Understood? So what is the work done by this external force? You know the formula for work done or not? F W is equal to F dot S vector. F is how much? 2SL. S is how much? Displacement is
Ln.
this is displacement, right? Write it as displacement D. It is X. And that is equal to change in surface energy of the system. Got it?
Yes.
If you want to write, you can write, but write it quickly, huh? All of you.
So, I won't be able to turn on my camera today as आज ही मैं घर आई हूँ तो थोड़ा नेटवर्क का सेट वगैरह करना है मेरे को.
अनन्या,
Yes, sir.
कोई बात नहीं बेटा. Done?
Yes, sir. Yes, sir.
You will be having this recording in the Physics Pro Gold course also. You can actually go and watch it from there also. Okay? Now, we have done till pressure difference inside and outside the water drop. Let me do an example here. Let's do one example, all of you. Okay? So it's a very simple example. A water drop of R radius. This is a water drop of R radius and surface tension S is broken into 8 water droplets. Okay? Of radius small r. Right. Now it says, what is the change in surface energy of this entire? What is the change in surface energy in this exercise? Right. From breaking a drop of radius r into droplets, 8 droplets of equal radii r. So what we will do here? First of all, we will find the initial surface energy. Okay. And what is that? Surface area, that is 4 pi r square into surface tension S. Understood, all of you?
Yes, sir.
This is the initial surface energy of this first drop, right? Now, for all the water droplets, it will be 8 into 4 pi r square into S. Now we want to find what is the value of small r. Okay. Now this is equal to what? This is 4 by 3 pi r cube is equal to 8 into 4 by 3 pi r cube. Right? So small r is equal to r by 2. You can solve it. 4 by 3 pi goes off. Right? From here I get r cube is equal to r cube upon 2 cube. When you take the cube root of it, you get this. So this is 8 into 4 pi r square by 4 into s. 4 cancels out. It is 8 pi r square s. So what is change in surface energy now? It is uf minus ui, which is 4 pi r square s. I hope all of you understood it. Yes or no?
Yes, sir.
Sir.
ठीक है. If you want to write it, but be quick, huh?
Certain.
Okay. हमारा समझ आया बेटा? हमारा आरव, मयंक,
Yes, sir.
शिव, शिव समझ आया है?
Yes, sir.
तारिणी, understood?
Yes, sir.
Okay. चलिए, let's move ahead to viscosity. Okay. See, we have already done in this session, in this batch, we have already done till pressure difference inside and outside the water molecules. Sorry, pressure, water drops and bubbles, right? Now, let's see rise and fall of, all of you please pay attention, rise and fall of liquid along the solid dipped in it. Now, all of you pay attention. The solid surface seems to be like this, right? It's a glass plate. Beta, please pay attention. This is very important to understand. All 11th standard students, right? And all 12th standard students, you see what is happening. You just remember the data points, okay? So this is a glass plate which we have. Okay. Now, this glass plate is dipped inside a liquid, let's say water, and the water will rise along this glass plate. So this is how it looks like. This is the layer of water, the topmost layer of water which is rising along the glass plate. All of you understood it or not?
Yes, sir.
Yes.
This is the layer of water. Okay. So I will remove it now. I drew it just to help you understand it. Now, what are the forces which are acting on this water molecule? This is the water molecule which we have. Okay. Now see what are the forces acting on it. Please pay attention. It is very important. First is its weight only, right? So this is the weight of the water molecule which is acting on it. The second force which is acting on it is the force of adhesion. Remember these terms, right? इस पे theory में questions पूछे गए हैं. This is adhesive force or force of adhesion. This is adhesive force. Okay. I'll just take it upwards if you need this space. ठीक है. Now, there is this cohesive force. Cohesive force is between water molecules. This is force of cohesion or cohesive force, and this is between the molecules of water. Okay. Now, we will draw tangential plane to the liquid surface. Please pay attention what I am trying to do. I am drawing the tangential plane to the liquid surface. So here, let's draw it with this color. This is the tangential plane drawn to the liquid surface. Okay. Now this tangential plane is always drawn this tangential plane. This is tangential plane drawn to the liquid surface. This is it. It is always drawn. Remember the statements, remember the conditions, please. It is always drawn away from the solid. Okay. So this plane is, I have drawn this plane away from the solid. This is the plane, right? Now, then comes, let's call this tangential plane by the liquid surface as TPS. This is TPL, sorry, not S, it's TPL. Tangential plane drawn to the liquid surface. Okay. Now draw tangential plane to the liquid solid surface. This is the tangential plane drawn to the solid surface. Okay. Now, what is it? It is TPS. Now remember, let me write, I'll write it for this also. This is tangential plane drawn to the solid surface. Right? It is always drawn towards the liquid. Right? Now, how many forces were acting on this water molecule? We have seen that. How many forces were acting here?
3.
It was W, Fa and Fc, right? The resultant of all these forces, is this force. This is the resultant of which forces? Fa plus weight plus Fc. Now, the resultant force, remember, if the resultant force is directed into the solid surface, right? The liquid rises along the solid. Remember this. So in this case, the liquid is rising along the solid because the resultant force is into the solid surface, right? Now, the angle between the TPS and TPL, this angle, the green colored one. Okay, this is called as contact angle. क्या बोलते हैं इसको? This is called as contact angle. So what is contact angle? It is the angle between, TPS and TPL. All of you understood it? Say yes or no.
Yes, sir.
Yes, sir.
Yes, sir.
So if theta is less than 90 degrees, that is, it is acute, right? Then also the fluid or the liquid rises along the solid. Now this was for, what was the combination here? It was glass plate plus water. Okay. Now there is a special condition. If the glass plate is dust free, अगर इस प्लेट में डस्ट नहीं लगा हुआ है, and water is pure water. Okay. This theta is equal to 0 degrees. Understood?
Yes,
This is
sir.
a standard data. All of you need to remember it. Now just go through all these, whatever I have written here, go through all these things. Okay? 2 times, 3 times, just read it first. If you have understood it, then only write it. If you have not understood it, just clear your doubts and then copy it. Pranav,
Yes, sir.
समझ आया नहीं आया बेटा?
Sir, yes, sir. एक और बार पढ़ ले तो sir, any
करो,
gaps
पढ़ो।
are there.
शिव, तुमको समझ आया बेटा नहीं आया?
Sir, yes.
जानवी, भवानी, हाँ बोलो बोलो।
Sir, theta मतलब अगर exactly 90 है तो
हाँ, तो ऐसा रहेगा वो जो 0 डिग्री रहेगा, पहले 0 डिग्री होगा तो क्या होगा, वो पूरा ऐसे चढ़ेगा, ऐसे साइड में लगा रहेगा।
हाँ।
90 होगा तो ऐसे हो जाएगा।
ठीक।
ग्रेटर देन 90 भी होता है।
Yes.
when theta is equal to 90 degrees, the fluid will neither rise along the solid nor it will go down along the solid, fall along the solid.
Okay.
जानवी को समझ में आया है कि नहीं?
Yes, sir, I got it.
Good. श्लेषा,
हाँ सर।
आया ना बेटा समझ में?
हाँ।
Anu, Anu is also here.
Yes, sir.
Understood?
Yes, sir.
Good. Chalo, if you have copied it, I'll discuss the liquid falling along the solid case. देखो. Now I am taking this cross section thing, huh? This thing I am taking just. So see this thickness. And now here what is happening is the liquid is falling along the solid. So this is how the falling liquid looks like. Okay. So this is the liquid molecule on which we will see the forces. First force is weight of it. Second force is the force because of the solid molecule, that is force of adhesion, right? And the third force is force of cohesion. So this is Fa, this is weight, and this is force of cohesion, right? Now, here the resultant force is directed towards the liquid. You can see here. This is the resultant of Fa plus Fc plus W, right? This resultant force if the resultant force is directed into the liquid, then the liquid falls along the solid. ठीक है बच्चों? Now let's draw the tangential plane to the liquid surface first. This is the tangential plane drawn to the liquid surface. This is TPL. It is drawn away from the solid. You can see here I am drawing it away from the solid, okay? And this is the tangential plane drawn to the solid surface. This is TPS and it is drawn into the liquid. Now check for this angle between them. This is the angle between them. And this is their contact angle theta C. You can see here that theta C is greater than 90 degrees. Yes or no? All of you.
Yes, sir.
Yes, sir.
Yes, sir.
Theta C 90 से बड़ा है. Right? This is an obtuse angle. Okay. So I'll write it again. If the contact angle is greater than 90 degrees, then the fluid or liquid falls along the solid. Bhavani, you understood it or not?
Yes, sir.
Sure?
Yes. Now, remember these conditions when the liquid falls
along the solid when the liquid falls, sorry, rises along the solid, right? Remember these conditions. Where are the forces directed towards? Whether they are directed towards whether they are directed into the solid or they are directed into the liquid, right? Remember what is the, where is the contact angle measured between? In which two planes the contact angle is measured, right? So then only you will be able to remember all these falling and rise of liquid along the solid. Now, standard data for dust-free glass, in this case, standard data for dust-free glass and mercury, pure mercury, theta C is what? Approximately 140 degrees. Okay, for calculation purpose, you can take it as 135 degrees. If all of you have done it, please let me know. We'll move ahead. प्रणव कर लिया बेटा? लिख लिया?
Yes, sir.
श्रृंखला लिखा बेटा?
एक मिनट सर.
Okay, Lakshit? Written? शिव तू लिख रहा है?
Done, sir.
2 मिनट.
लिखो लिखो.
Excuse me, sir.
Yes.
So what if the glass is dusted?
What is?
What if the glass is dusted?
Then
Does the contact angle change?
you are Tarini.
Yes, sir.
Okay. Tarini, actually see what happens is then there will be, the angles will be lesser than what is required, right? It will be greater than 0 degrees for dust-free glass and pure water, for water only. It's close to say 8 degrees, 9 degrees types. Okay. You keep mixing the impurities, then also the angles will change.
Okay. Yes, sir.
So these angles are for ideal cases. Okay. All of you done with it?
Yes, sir.
Sir,
Now
Yes,
it
sir.
the last point where you wrote about the pure mercury, could you explain it again?
Which one? Dust-free glass plus pure
Dust-free.
mercury.
Yes, sir.
See, if there is a dust-free glass and pure mercury, it is dipped in a pure mercury thing. Okay. Then the contact angle is approximately 140 degrees. This is a standard data which you should remember. If in case the data is not given to you, then you should take it as, for calculation purposes, you can take it as 135 degrees.
Okay, sir. Like, is there any reason why the angle is
See, these
that
are all
much?
practical, these are all standard data, right? They have been measured in the experimental setup. Right.
Okay, sir.
Why it is falling and why it is rising, there is a reasoning behind that. So we have all these things, all the reasons are written here. Okay.
Okay, sir.
So now let's discuss about rise of liquid in a capillary. All of you have seen capillary tubes? Yes or no? Just type yes or
Yes,
no.
sir.
Okay.
Yes, sir.
If you have seen it, very good. If you have not seen it, please go and check it in your labs. Okay. So if the tube is dipped in water, right, what happens here is the water starts rising inside it. And this is the primary reason, capillary action is the primary reason why water from roots of the trees are sent to the tip of the leaves of every branch. Okay. So we are assuming that this is water and this is how it looks like. Okay. The water is not pure, so the contact angle is not purely 0 degrees. Okay. Now, all of you imagine it that the periphery of the fluid, which is a circular periphery. You can imagine it or not? If you cannot imagine it, go and bring water in a glass and you can see that it's slightly rising like this. And it's a circular thing. Okay, I'll draw it here. You can see it. This is the periphery of the topmost, the free surface of water. This is the periphery of free surface of water, right? And what will happen here is we are taking small portions here. Okay. And these will be pulled because of the surface tension S. Let's say these lengths are what? How much length? DL is the length, right? So these forces are, let's call these forces as DF. So this is SL or SDL and this is DF. Right. Now, we have these components of the forces. This is contact angle theta. So this is dF cos theta. And this is also dF cos theta. Okay. Now the net force because of surface tension, the net force because of surface tension is how much? It's the integral of only the cosine components of all these df's. So this is S cos theta into dl. Cos theta is a constant, surface tension is a constant value. So S cos theta is integral of dl. This is we are integrating it from 0 to 2 pi r. Now what is this 2 pi r? It is the radius of this tube. This is r. We are observing all the lengths of on the periphery of this free surface. Understood or not? Bhavani?
Yes, sir.
Understood? ये समझ आया बेटा नहीं आया?
Yes, sir.
पक्का?
Yes, sir.
Now anybody is having any doubt in this particular explanation, please ask. Shiv, Pranav?
No, sir.
This is Fs. Okay. अनन्या समझ आया बेटा? अनन्या, हमारा आरव?
Yes, sir.
So this Fs is acting upwards on this liquid column, I can say. And this is Fs, which is equal to 2 pi r s cos theta, where theta is the contact angle. I have already shown it to you, but I'll show it to you here also. This is the contact angle, right? This angle is the contact angle theta. Now, let's assume that some H column of fluid has moved upwards inside it, inside the tube, right? This length is H. Density is rho. So what is the weight of this portion? Weight of this column is how much? W is equal to H rho cross section area, which is pi r square, into G. Yes or no? H into pi r square is the volume of that portion of water which has risen inside the tube, right? H is height, pi r square is cross section area. So we multiply it, we get volume. Volume into density is mass. Mass into g is weight. So these two forces, that is weight, is now balancing this Fs. Weight is balancing this Fs. Okay. So we have 2 pi r s cos theta is equal to h rho pi r square. Sorry, it's r square into g. So we have h as 2s cos theta upon rho r g. I hope all of you understood it. Just go through it once again and check if you have any problem or doubt. शिव समझ आया बेटा? नहीं आया? 11th में है, डेरिवेशंस में, ठीक है, प्लीज चेक.
Okay, sir.
All of you. If you have copied it, if you're done with it, please do let me know.
Sir, done.
Completed, sir. Completed.
Shlesha, very good. I solved 45 questions of electrostatic. बहुत बढ़िया बेटा, शाबाश.
Completed, sir.
Chalo, if you have completed it, so let's move ahead. Now there is a special condition here. There is a special condition here. We will look into that first, and then we will move ahead. When R is equal to 0 degrees. What happens when R is equal to 0 degrees? Sorry, not R. If R is theta is equal to 0 degrees, right? Now, how will it look like? See, this is the tube. And inside this tube, we will have this fluid. Dekhte jao beta. This is the fluid. And now what we are doing here is, let's draw a circle here. So the meniscus will almost be a semicircle. Meniscus will almost be a semicircular portion. Okay. So here you can see that the tangential plane, both the tangential planes are having 0 degree ka angle. Okay. Now, if this is the portion till which we assume that this was H, right? Here, if you draw it, it looks like this. All of you, please pay attention. How much portion of water is left out? This much portion of water is left out. Yes or no?
Yes,
Now,
sir.
if we are able to include this much portion also, then our answer will be more appropriate or more correct, right? You understood what I'm trying to do? Hello?
Yes, sir.
Yes, sir.
Yes, sir.
Okay. Okay. So now what about the weight of the liquid now? Weight of the liquid will be, see, this pi r square remains as it is, right? Then rho remains as it is. G remains as it is. The only thing which will change is H plus R was the height up to this point. This is R and this was H. Okay. But from this volume, I have to subtract the volume of this hemispherical volume. I need to subtract this hemispherical volume, right? So it is minus 2 by 3 pi r cube. I hope all of you got this.
Yes, sir.
into rho into G.
Yes, sir.
वॉल्यूम इंटू डेंसिटी इंटू जी. ठीक है, तो इतना इसे एलिमिनेट करना है. सो वी हैव रो जी, आर स्क्वायर इज आर स्क्वायर, पाई इज पाई. व्हाट वी आर लेफ्ट आउट विथ पाई आर स्क्वायर, रो जी इज देयर, एच प्लस आर minus 2 by 3r, or it is rho pi r square g into h plus r by 3. This is weight, right? And now equate this weight to 2 pi rs, because cos theta is 0. So equate this force Fs, which is 2 pi rs, to W, which is rho pi r square g into h plus r by 3. ठीक है बच्चों? So this pi cancels out. This is small r, huh? This cancels out. This is 2s upon rho rg minus r by 3 is the height of the liquid which has went up in the tube. लिक्विड के अंदर इतना हाइट गया वो, सॉरी ट्यूब के अंदर लिक्विड. ठीक है, ऑल ऑफ यू अंडरस्टूड इट और नॉट?
Yes, sir.
This is the
Yes, sir.
case. This is the case when we are taking theta as 0 under ideal conditions. Pranav, Shiv,
Yes,
Yes,
sir.
sir.
any doubts?
No.
एक बार just go through it. If you have any doubts, please ask. Bhavani, Shlesha, Shrinkla, Tarini, Amara, Ananya,
Got
Janvi, Anu.
Got it, sir.
Good. Written, done with writing the, done with notes?
Say 1 minute.
करो करो करो, आराम से करो, कोई दिक्कत नहीं. प्रणव, हम लोगों ने एसएचएम कर लिया है क्या? सिंपल हार्मोनिक मोशन हो गया है?
सर 1 मिनट सर.
देखो देखो,
नहीं है.
नहीं हुआ है ना?
वो तो नहीं हुआ सर.
इसके बाद ही है ना चैप्टर वो?
यस सर, चैप्टर तो नहीं हुआ सर.
नहीं नहीं, इसके एचसीवी में इसके बाद है ना?
एचसीवी में सर 1 मिनट देख लेता हूँ.
If you are done with writing, let's move ahead. Janvi, done? You understood or not?
Understood.
Good.
सर ग्रेविटेशन के बाद.
हम लोगों ने मतलब स्किप कर दिया वो.
हाँ सर.
अच्छा, ये अगर ये चैप्टर उसमें आ रहा था इन लोग के एग्जाम में, इसलिए किया था ना अपन ने. फ्लूइड्स कर लिया ना? क्यों शिव?
यस सर, फ्लूइड्स कर लिया.
Yes.
ठीक है, तो एसएचएम बचा, एसएचएम करेंगे पहले.
यस सर.
श्लेषा, ऑलरेडी मॉडर्न फिजिक्स पढ़ा चुका हूं मैं, ऑप्टिक्स और मॉडर्न फिजिक्स 12th में, पर एक बार दोबारा पढ़ा रहा हूं मैं अभी. ठीक है, तो उसकी क्लास अलग से होगी संडे को आफ्टरनून में. तो
संडे.
हाँ, मतलब आई टेल यू द टाइमिंग्स. If not this Sunday, then tomorrow I have many classes scheduled. So this was an extra session which I wanted to plan. So tomorrow will not be possible, but from next week we will be doing regular classes for optics and modern physics only on Sundays, right? And meanwhile we will be doing our regular sessions, which I have the schedule of which I have already given to you. Okay. So this is what is the plan. So this is rise of liquid in a capillary. Now comes the next topic, which is viscosity. Now, what is viscosity? It's force, a force which opposes the relative motion between the layers of fluid. Is called as viscous force. Okay, and the property is called as viscosity. Now remember, if we have these layers of fluid, right, these are different layers of fluid, and suppose some object starts moving at the topmost layer, say a ship or a boat. Okay, this boat starts moving with some velocity, say v, right? Then it will take the topmost layer along with it. It will take the topmost layer along with it. So the topmost layer will have a velocity v. Okay. Now, because of viscosity, now we are not talking about an ideal fluid, huh? Because of viscosity, the velocities of the lower layers will keep on decreasing, right? And the velocity of the bottommost layer, which is in contact with the ground, will become zero. So this is how the velocity is gradually decreasing. Let's say the distance between two layers is dz, the two heights is dz, right? And here the change in velocity is dv. So I'm writing the velocity of the next immediate layer below the first surface, below the top surface, is v plus dv. Here dv will be negative, then only it will decrease. Okay. So it says the viscous force is proportional to the velocity gradient, right? Is proportional to area of contact between two layers of fluid. Okay. And the proportionality constant happens to be eta, and this is the viscous force is given as eta A dV by dz. This is also called as Newton's law of viscosity. Okay. So this is the viscous force. Now let's try to find out what is dimension of this coefficient of viscosity. Eta is what? Eta is coefficient of ठीक है, तो ये क्या हो जाएगा? This is dimension of f upon dimension of a into dimension of dz upon dimension of dv, right? What is dimension of f? It is mlt minus 2. What is dimension of area? It is L to the power 2. dz is what? It's change in length, change in height. So it is L. And what is v? It's Lt minus 1. So this is m power 1. This cancels out. This cancels out. It's L power minus 1. And this is t power minus 1. So dimension of coefficient of viscosity is m to the power 1, L to the power minus 1, t to the power minus 1. I hope all of you understood it. Just say yes or no.
Yes, sir.
Yes, sir.
Yes, sir.
Copy it. Bhavani, you understood it or not?
Sir, can you please explain how V plus dV?
Uh-huh.
V plus dV.
Uh-huh. You want me to explain it?
Yes.
See, there is a change in the velocity, right? Yes or no?
Yes.
So let's the change is dv.
Mm.
Okay. Now I am writing that the next layer's velocity as v plus dv. Okay. Hello.
I didn't.
अरे तुम just what should I say? Just keep doing whatever I am saying as of now. Okay. The topmost layer's velocity is v. Okay.
Yes.
There is a change in the next layer's velocity, that is dv. Okay.
We need to minus, right?
अरे रुक तो जा बेटा, पहले सुन तो. Just listen to it. See, if that dv is negative, if that dv is negative, right?
Yes.
Then the next layer's velocity is decreasing or not?
Yes.
That is why we have put a negative sign here. That is why we have put a negative sign here. Understood or not? This dv by dz is a negative thing, right? Got it or not?
Yes.
So, see, whenever there is a change, we always write that change as plus dv or z plus dz, right? Now, if this is a negative thing, then the ultimate change will be taken as minus dz. If this is a negative thing, then the ultimate change is taken as minus dv. Understood?
Yes.
But we write it as v plus dv. The change is how much? Change is of minus 2, say. Okay? To understand,
Yes.
change is of minus 2. But we will write it as v plus dv, and then when we are substituting dv as minus 2, automatically it will decrease by a factor of 2, by a value of 2.
Yes.
चलो, तो ये हो गया. Viscosity done. अनन्या समझ आया बेटा, नहीं आया?
Yes, sir.
और मयंक गायब हो गया इसमें से.
Yes.
सर मैं हूँ सर.
कौन गायब हो गया? 14 लोग थे, अभी 12 लोग हैं. 2 लोग. तारिणी इज देयर, जानवी इज नॉट देयर. और कौन है? प्रणव प्रसाद नायर. वो चला गया. शिव समझ आया बेटा, नहीं आया?
Yes, sir.
ठीक है. तो so this is for today, right? This was for today, and in the next session we will be completing this entire topic. ठीक है? That is on Tuesday. ठीक है. So what is left is Poisson's equation is left in this particular viscosity. Second is Stokes' law is left. Third is terminal velocity, and fourth one is Reynolds number. So these 4 topics are left. We will do that on Tuesday, and we will complete this chapter. Next chapter we will be starting, which will start is simple harmonic motion, and after that waves and thermodynamics. Okay, this is what is left in 11th standard portion. So I hope in all probability I'll be completing all this portion by 20th of January. 11th standard portion. Okay. 12th standard portion will be completed by then, because I'll be increasing the frequency of one extra session I'll be taking for this optics and modern physics on Sundays, and on the rest days we will be able to do that. As of now, which chapter we are doing, Amara? In 12th standard, we are completed with Gauss's law, right?
Yes, sir. We completed with Gauss's law. Now we are doing.
Capacitors.
We haven't started.
We haven't started, na? ठीक है. So how many chapters of 12th standard are left as of now is capacitors, current electricity, magnetic effects of current, magnetic field, EMI, AC, EM waves. So 7 chapters. क्या बेटा?
So
Yes,
nuclei.
you said you will do.
न्यूक्लियाई अच्छा किया नहीं है क्या अपन ने उसमें?
No, so आपने
हमारा
बोला था
display
कि
किया
हमने
था।